This is the part 2 of the video series on Pythagorean triples. The video link of the part 1 is given in the description box below. Please watch that tutorial first if you haven't watched already, because whatever we are going to discuss here is connected to that. Okay, so you'll better understand whatever we discuss here. Now let's begin our discussion. We have a problem here. Write a Pythagorean triple whose smallest member is 8. Now we know that we can calculate Pythagorean triples using three algebraic expressions, that is 2m, then m squared minus 1 and m squared plus 1, right? Where m can take any value of a positive integer which should be greater than 1 and should be a positive integer. So this much we know. Okay, since this is a Pythagorean triple, you can go on putting different values of m like 2, then 3, then 4, then 5, and for each different value of m you'll get different Pythagorean triples, different sets of Pythagorean triple. So let's say that this is x, this is y, and this is z. From this we know that since it is a Pythagorean triple, it means x squared plus y squared is equal to z squared, where z is actually the largest of these three, is the largest one. It means that 2m squared plus m squared minus 1 whole squared, this is equal to m squared plus 1 whole squared. Okay, and this will m squared plus 1, this will give you the largest value of the largest member. So this is asking for the smallest member is 8. It's given that the smallest member is 8. So when we begin our solving this problem using the assumption method that we have discussed in the part 1, that's why I'm saying please watch that tutorial first. In that assumption method, you'll ignore this one, m squared plus 1. That is, you will not check for m squared plus 1 is equal to 8. Why? Because we have already discussed, like from here you can see that this z, that is m squared plus 1, is actually the largest of these three. Therefore, there is no way that z can give this m squared plus 1 will represent the smallest member, right? Okay. So it means that the assumption method will be used in two different ways. The first one is like your m squared minus 1. Let's assume that this is equal to 8. That is 8 is actually y. Okay, let's assume that 8 is equal to y. So from here, if you solve it, you get m squared is equal to 9. And from here, if you put m is equal to 3, then you get actually m squared is actually 9. For m is equal to 3, this is true. Now some of you will say that, hey, you know what, we can even put m is equal to minus 3, because minus 3 squared is equal to 9. Yes, you are correct, but minus 3 cannot be correct here, will not be correct here, because m can only take values that are greater than 1 and positive integers, right? So this is neither a positive integer nor greater than 1, right? Okay, so m is equal to 3. It means that this assumption is correct. That is, if we assume that m squared minus 1 is equal to 8, then we are getting m is equal to 3. But let's assume that, check for this one also. That is, let's assume that 8 is this 2m. So 2m, that is x, 2m is equal to 8. From here, you get m is equal to 4. Okay, you get m is equal to 4. Now, you'll say that, hey, even we are getting an integer value here, m is equal to 3. And m is equal to 4 is also an integer value. Now, this time we are getting two integer value. Which one is correct? That's why I said that it's important to check this one also. Now, let's take this one. That is m is equal to 3. So if you take m is equal to 3, and if you try to find out this value, that is 2m, 2m means what? 6. Then 3 squared means 9, minus 1 is 8, and then 3 squared 9 plus 1 is 10. So the value that you are getting here is 6, 8, 10. Okay, check for this one, that is m is equal to 4. When you put m is equal to 4 here, you get 8. Then m is equal to 4 here means 4 squared is 16 minus 1 is 15. And 4 squared 16 plus 1 is 17. Okay. Now, if you check this one and if you check this one, in this Pythagorean triple, actually 6 is the smallest value. That is 6 is the smallest member and not 8. But if you check this Pythagorean triple, then 8 is the smallest member as per this question. It satisfied this condition. But it means that when you take m equal to 3, then that's actually giving you a Pythagorean triple. But in that Pythagorean triple, 6 is the smallest member and not 8. That is why this assumption is wrong. And that is why it's important to check each and every member, right? Each and every x, y, and z in this case. So you can clearly see here, when we solve for m square minus 1 is equal to 8, and that is we assume that y is equal to 8, and then we assume that x is equal to 8, this assumption is correct because this is giving you whatever is required in this question.